Today is the day. Today is the first day that I apply power to the Wiltron 360. I've unpacked it, I've stacked it up in the rack, I've cabled it up, I've checked it to make sure that everything's okay. There's nothing else left for me to do except to switch it on. Nothing else except to give you a quick tour of what's down the back, because there's quite a bit going on there. And also to show you an important feature that someone has added to this rack during its lifetime. And that is as simple as being able to turn it around. It's on wheels. And without this feature, it would be extremely difficult to move this. Starting at the top, we've got the VNA itself, which is intimately linked to the test set via the pair of cables here. These cables transfer power, signal and control. There's no on-off switch on the test set. Everything comes through these cables here. There's the coax cable here that has the phase lock signal. So very important that the VNA is locked in phase to the signal source. And the VNA controls the signal source via this internal GPIB bus connection. For external control, there's a separate GPIB bus connector here, so you can plug in your own computer and run your own programs. And the VNA has an extensive GPIB instruction set. But in addition, there's other connectors here. There's a printer connector, there's an external CRT connector, composite video, and a few other miscellaneous connectors. But the main ones are the ones that I've pointed out here. Okay, I've set up the 360, checked all the wiring, consulted the manual to see if there's anything special I need to do to power this thing up. And now it's time to apply power and see what happens. And what I have here on the front is a power meter. It's an AliExpress special, so when I switch that on, it'll display the volts and the power that is being consumed by the 360. This is a routine piece of equipment I use when first powering on, just to make sure everything's going okay, and we'll see what happens. Okay, so putting power on. Switch on the power. There's nothing switched on at the moment, so there's power there. It's showing 0 watts power being consumed. I'm just going to add a little block wedge under here just to make that easier to read for the camera, but at the moment it's showing 0 watts. And we've got power on to the cabinet, but the units themselves are switched off. So what I expect to see is a message saying that the disk is not loaded into the machine, and I expect to see error messages because I've been told already that the signal source, there is a suspicion or reality that there is a fault with that. So let's see what happens. First I'll switch on the signal source, and we have got 146 watts. I can hear 143 watts, so that's looking okay. I can hear fans spinning in the background, so that's all looking good. Okay, nothing's blowing up, can't smell any smoke. Let's switch on the main unit. Alright, I can see LEDs, I can hear fans. What have we got? We've got 450 watts, so that's good. That's well inside the expectations. I've got error messages coming up, which is what I expect. Disk drive not ready, that's what I expected to see. Okay, let's see what else comes up. Right, disk drive not ready, that's good. Check the disk, press enter to try again. Okay, that's all good. Happy with that. It should be doing a self-test, but I'm not seeing any sign of that. But the fact that there's no other error messages coming up is a positive. I'm not going to load the disk in because I don't know the condition of either the disks or the floppy drive, and the last thing I want to do is risk wrecking or corrupting the data on the floppy disk. I do have 2 copies, so if one fails, I've got a backup. But what I want to do first is get a disk image that I can save to my computer, so that if there's any problems with the floppy drives in the future, that I can recover from it. And I'm actually planning on replacing the traditional floppy disk drive there with a modern diskless emulator. It's just solid state. Plug it in with a USB and I can store multiple images on that electronic equivalent of a mechanical floppy disk. So everything's working at the moment. I've got 417 watts, which is good. Right, so that's well inside the 650 watts specified as maximum load. No smoke. Fans running. Everything's looking good. Okay, well that's a positive. Right, that's a positive outcome. Okay, I've thought about running a software on the floppy drive. I was worried about mangling a really old 30-year-old, 35-year-old floppy disk. But I remembered that I've got multiple versions. So I'm going to try running a version 3.01, which is about 3 or 4, well, 8 versions before the latest version that I have. So let's see what happens. What I expect to see is 1 or 2 error messages. It's a bit, okay, we'll plug that in. Oops, I actually put that upside down. It's so long since I've put on a floppy disk. There we go. And enter. Right, so it's reading it now, loading program from disk. Clickety click. Clink clink, clickety click. It's been a long time since I've heard a 3.5-inch floppy disk making noises. Okay. No error messages. Well, that's good. None at all. Alright, so superficially anyway, the system, what is we doing? Got some graphing, let's have a look. Oops. Lock failure. Okay, I have got an error message. So that's what I'd expect if the source is not generating the correct frequency. So what am I looking at? Looking at gigahertz. Okay, so it looks like at the lower frequencies, if we look at this graph down here, it's produced a signal and then it's said there's a lock failure. So I'd say that the upper part of the frequency bands, the source, is not working properly. That's what I expected. A lock failure has occurred for some reason. So that's what I expected, and that's what I need to try and fix. That'll be a challenge. But anyway, the software loads. I've got an expected error message, lock failure. So the challenge will be now to try and fix it. But apart from that issue, that's the only error message I've got. So again, that is an expected outcome. I won't say that having a lock failure is a positive outcome, but it's an expected outcome. Okay, so there it is. The Wiltron VNA has powered up. All the lights are flashing, the fans are running, there's no smell of smoke, and it works, with the exception of that one fault that I knew about. So the next phase in what I need to do is to figure out how I'm actually going to fix that fault. I don't have the test equipment to work at 40 gigahertz, and so it is going to be a challenge.